Okay, this is part 2 of our review, which goes over module 3, which was our polynomials and our radicals. So for the first one, we are adding polynomials together. So when we add polynomials together, all we have to do is simply combine like terms. So for example, we have y squared and y squared. So 2 plus negative 3y squared would be negative 1y squared, or just negative y squared. We have two y terms. We have a negative 8y and a positive 3y. That would add to a negative 5y. And then we have a 4 and a negative 5, which would add to negative 1. So there's my sum polynomial, just adding together the like terms. Okay, let's look at number 2. Number 2, we have multiplication. We have two binomials in this case. So if I want to solve for these, I will just simply FOIL this. So it will be 2x times 8, which is 16x. So we're just matching up the terms. 2x minus 3x is minus 6x squared. We have negative 7 and positive 8, which is negative 56. And we have the 2x and the 8. Nope, we already did that when we have the negative 7 and the negative 3x, which is positive 21x. So if I try to look at this, I could put these two together because they both have the x. I'm just going to put it in kind of a descending order, so I put the square first. 16 and 21 is 37, so this is 37x, and this would be minus 56. All right, let's look at number 3 where we are dividing. We're dividing a squared polynomial by a binomial. So we can use our synthetic division. So if you remember how that works, all the numbers that are in front of our polynomials here go on the top row. So 1, negative 9, and 14. If one is missing, like if we started with a cube and there was no squared, we put the 0 placeholder. Not in this case, but other cases you can. And on the outside, we put what would I plug into x to make the bottom 0? Well, 2 minus 2 would be 0, so I put a 2 outside of here. So if you remember how this process works, we bring down the first term, which is 1. I multiply the number on the outside times that. 2 times 1 is 2. Negative 9 plus 2 is negative 7. 2 times negative 7 will give us negative 14. So in this case, it gives me 0 remainder. Remember, this is always our remainder. So my answer, since this started with a degree 2, my answer starts with 1 less. So this would be 1x to the first, or just x, minus 7. Okay, this next page deals with factoring polynomials. We have some of the 3-term. We have some of the 2-term. So the first thing I should always look for is a greatest common factor, which we have 1, negative 8, and 20. That does not have one. So we'll try to factor it into 2 binomials. So remember, we multiply the first and last term, which in this case is negative 20, times 1, which is just negative 20. So we want to figure out, are there 2 numbers that multiply to negative 20 and add to negative 8? And there are. That would be negative 10 and positive 2. Those multiply to negative 20, and those add to negative 8. It's got to multiply to this number and add to this number. So it might take you a little time to kind of figure out what those are. So when I factor, I put my x squared here, I put my negative 20 here, and then I will put these numbers, negative 10x, and I will put 2x in my boxes. So if I look at the first row, I can take out an x. If I look at the second row, I can take out a 2. If I look at the first column, I can take out an x. And if I look at the second column, I can take out a negative 10. It's 10, but since the first term is negative, we always take the negative out. So that gives us our 2 factors, x plus 2 and x minus 10. Factoring will be a really important skill when we get into the second semester, so this is a really good skill to have. So let's look at the next one. This is number 5. So same idea, no GCF because 3 and 6 divide, but 7 doesn't. So 3 times negative 6 is negative 18. So I'm looking for two numbers that multiply to negative 18 that add to negative 7. That'd be negative 9 and positive 2. Okay? Those add to negative 7, those multiply to negative 18. So in my box, I have 3x squared, I have minus 6, I have minus 9x, and I have 2x. So if I look at the first row, I can take out a 3 and an x. And if I look at the second row, I can take out a 2. So that's going to be one of my factors. Now if I look at the columns, this one I can take out just an x, because 3 and 2 don't have anything in common. And 9 and 6, you can have a 3. But again, since this first guy is negative, we're going to take out negative 3. So our two factors are 3x plus 2 and x minus 3. So our last factoring problem is going to deal with these two-term kind of problems. So we have 8x squared minus 98y squared. So the first thing I'll do is look for a GCF, which we have in this case. These both divide by 2. So I can take a 2 out, so that leaves me 4x squared minus 49y squared. So what we look for is, can we factor this? Well, if there's two terms, the only ways we could factor that is with difference of cubes, difference of squares, or sum of cubes. And this is difference of squares. Because 4x squared is 2x times 2x. 49y is 7y and 7y. So this factor is difference of squares as 2x minus 7y, 2x plus 7y. So just those two terms, one with a plus, one with a minus. But don't forget to bring your GCF down. Don't forget to bring that number you took out at first. All right, number 7 says express y to the 2/3 in radical form. Now, if you remember these rational exponents, the bottom always gives us the index of our root, and the top always gives us our power. So if I'm rewriting this as a radical, the index of the radical is the bottom number, which is 3. So this is a cube root. So then we have our y, and this is all squared. So this index, the bottom number relates to this, and the top number relates to the power. So if this y was a number, we could try to simplify it, but we can't, so we just keep it like this. All right, so number 8 says we want to simplify this radical expression, radical square root 288. So when you're simplifying a radical, this is when we break it down. So I can break this down. 288 is 2 and 144. 144 is 12 and 12. So I can really stop here. I can break it down to my primes, but I see here I have a group of 12s. And then I have a 2 left over. Now, if you break it down, you could break it down and get 2 groups of 2 and a group of 3. But since I see this so nicely, I know the common group goes on the outside, and then whatever's left side goes on the inside. So this is 12 radical 2. Now, if you did break it down more, it'd be 2 and 144, then you could go 12 and 12. And this would be 4 and 3, so there's a prime. 4 and 3, there's a prime. 2 and 2, there's a prime. 2 and 2, there's a prime. So if I were to do it this way, I get the same thing, because you can see I take one group, 2 groups of 2 out, and then a group of 3 out. But 2 times 2 times 3 is 12. So it doesn't matter. We got kind of fortunate because I saw that group there, but it doesn't matter. All right, so the next couple of problems, we're going to try to perform these radical operations. Now, the first thing you should always do is you should try to simplify your radicals on these problems. Now, these radicals are just radical 5, so those are not going to go anywhere. And since we're trying to subtract them, we can because these are like radicals. If your radicals are the same, you can subtract them. So 3 minus 5 is simply negative 2 radical 5. And again, you could only add or subtract when you have like radicals, which is the stuff underneath the radical sign. Okay? So if you look at 10, we cannot add these together right now. Because look, we have a 12 and we have a 300. That doesn't work. Well, let's try to break it down. So 12 is 4 and 3. 3 is prime. 2 and 2. Those are prime. So I have one group of 2's that come out. So for this term, I have the 3 that was already there. I can take a 2 out because I have a group of those, and I'm left with 3 on the inside. Now for the next one, I start with a 2 on the outside, then I have to break down 300. So that's 3 and 100. That's 10 and 10. That's 5 and 2, 5 and 2. So if you see, I have a group of 5s and a group of 2's with a 3 left over. So I'll take a 5 out and a 2 out and left with 3. Well, now look, those radicals are going to match. So this is going to be 6 radical 3, because 3 times 2 is 3. 2 times 5 times 2 is 20 radical 3. So 6 plus 20 is 26 radical 3. Okay, let's look at our last one, number 11. So this one we have two radical expressions, which are binomial. So if you have two radical expressions like this, we'll FOIL. Anytime you have two binomials, good idea to FOIL. 2 times 2 is 4. 2 times radical 6 is 2 radical 6. Inside is minus 2 radical 6. And the last would be minus radical 36. Well, quite conveniently, these middle terms, both are radical 6 and they're opposites, so those cancel. So we have 4 minus 6, which is negative 2. All right, hopefully this is helpful. Your second part of your midterm review, we will have one more to go.